So we know that acids and alkalis, when they mix together, they form salt and water. And this process is called neutralization. Neutralization. Now we're going to talk about the quantitative aspects of neutralization. All right. Let's start off with a classic example of having hydrochloric acid mixing with an alkali, sodium hydroxide, and we get sodium chloride aqueous that's soluble in water, in soluble salt and water. All right. Let's talk about the quantitative aspects of that. From this balanced equation, we can determine that when you have 1 molar, which is the concentration, molar is the concentration, 1 molar, which equals to the moles over the volume. Okay, so in our units, we'll be talking about moles over volume, and this is molar. So when we have 1 moles, from this equation, we can see that 1 moles of hydrochloric acid will react with 1 moles of sodium hydroxide to give us 1 mole of sodium chloride and 1 mole of water. When we put this in terms of concentrations of the acid or alkalis, we'll talk about 1 molar of hydrochloric acid reacting with 1 molar of sodium hydroxide. And this, because this reaction is a 1-to-1 stoichiometric ratio, so you only need 1 molar of hydrochloric acid reacting with 1 molar of sodium chloride. So what this tells us is that when you have concentrations of the acids and alkalis to be the same, the concentrations of the acids and the alkalis are the same. The volume that you use to neutralize the acid and alkali is also going to be the same. So for example, if I said I'm going to use 1 cubic decimeter of sodium hydroxide, I will also use in 1 molar concentration, I will also use 1 cubic decimeter of hydrochloric acid of 1 molar concentration. Oof, that was a bit of a tongue twister right there. And we can equate this relationship using a ratio equation known as M1V1 or MIVI, which is the initial molar concentration as well as the initial volume, equal to the M2V2 or M final, V final, the molar concentration, the final molar concentration, and the final volume concentration. And we can use this equation to solve very simple stoichiometric problems. For example, if I had 2 molar concentration of hydrochloric acid reacting with 1 molar concentration of sodium hydroxide, and if I used 500 cubic centimeters of 2 molars hydrochloric acid, how much volume of 1 molar concentration of sodium hydroxide would I use? Plug this into this formula, and you will have 2 molars with 500 cubic centimeters. You should convert this centimeters to decimeters. So 0.5 cubic decimeters equals to 1 molar of the sodium hydroxide and the final volume that we're trying to solve. Plug this in to rearrange everything, and you should get 1. Let me do this slowly. So 2 molars and 0.5 cubic decimeter over 1 molar. Here, after you rearrange it, you notice that you can cross out the units, and what units that you're left with is the cubic decimeter. And when you put that in, you will see that you will need 1 cubic decimeter of sodium hydroxide, which equals to 1,000 cubic centimeters. Okay? That's pretty easy. Now let's switch over and talk about slightly more complicated acids and alkalis. In this case, I'm just going to use acids as an example, and you can apply the same concept to the alkalis. I'm going to use what we call polyprotic acid. Poly means many, protic means that many of these hydrogen ions, all right? And I'm going to use a polyprotic acid reacting with monatomic sodium hydroxide, okay? So here I have a sulfuric acid, which is a diprotic acid. That means each sulfuric acid molecule will have 2 hydrogens inside. Reacting with sodium hydroxide, this should be a 2, all right? And I'll get sodium sulfate and water. And what you notice is that in this balance equation, you will have not a 1-to-1 molar ratio, but you have 1 moles of this reacting with 2 moles of this. And the reason being is because of this being a diprotic acid. So you have H plus here and an H plus here. Okay? So when 1 mole of sulfuric acid reacts, when you react 1 mole of sulfuric acid, you need 2 molars of sodium hydroxide. And again, why? It's because each mole of sulfuric acid would yield 2 moles of hydrogen ions or protons. So again, we can use this formula to kind of do some quantitative calculations in terms of stoichiometric solution problems that we have here. So for example, I have 2 molars of sulfuric acid reacting with an unknown quantity of unknown concentration amount of sodium hydroxide. But we used each of these solutions, we managed to use 1,000 cubic centimeters of sulfuric acid and 1,000 cubic centimeters of sodium hydroxide. So these two when they react will neutralize to form the salt. So the question is, how much sodium hydroxide is over here? Well, I know that you probably can solve this equation in your head, but let's plug it into this formula. Now, because this is a diprotic acid, you need to multiply 2 for the concentration of the sulfuric acid, and I'll convert cubic centimeters to cubic decimeters, and I'll put this as the initial, and the final molar concentration is some unknown molar concentration multiplied by 1 cubic decimeter. And I'm trying to solve for this unknown concentration of sodium hydroxide. So what do we get right now? So we can get the final molar concentration to be 2 times 2 moles of the sulfuric acid multiplied by 1 cubic decimeter over 1 cubic decimeter. That is the volume of the sodium hydroxide. Okay? Again, this unit, the cubic decimeter units will cancel out, and what you're left with is 4 molars of sodium hydroxide. So with this kind of simple equation, you are able to quantify neutralization reactions.